So, have you ever actually wondered where that famous yellowish-green digestive fluid we call bile comes from? Seriously, take a second and think about it. Because if you asked most people on the street about their biliary system anatomy, they'd almost certainly point to one very specific, pear-shaped organ. But here's a massive hint. It is absolutely not the gallbladder. I know, right? No way! The gallbladder gets all the credit, but it's really just a storage tank. To actually understand how your body breaks down fats, we have to look at the whole picture. Today, we're diving deep into biliary system anatomy, mapping out the exact pathways that keep your digestion running smoothly. Welcome to This Explainer. I'm super excited to guide you through this whole biological network. We're going to trace the wild journey of bile, starting all the way up from the microscopic factories hidden inside your liver, right down to the small intestine. By the end of this, you're going to completely understand the gallbladder, the bile ducts, and how the whole shebang works together. Okay, the easiest way to think about the biliary system is like your body's own highly advanced plumbing network. It's just a series of connected pipes and tanks. Your liver, that's the manufacturing plant where the bile is actually made. The gallbladder is the storage warehouse. And the biliary tree is that complex system of pipes that collects, transports, and eventually dumps the bile right into your duodenum, which is just the very first part of your small intestine.
Section 1. Meet the biliary system and bile.
Before we trace the pipes themselves, we really need to talk about the fluid flowing through them. Bile is basically your body's custom-made dish soap. You know how dish soap instantly breaks down the grease on a dirty frying pan? Bile does the exact same thing to fats and fat-soluble vitamins, like vitamins A, D, E, and K, breaking them into tiny droplets so your intestines can actually absorb them. It's a mix of water, cholesterol, bile salts, and enzymes. But here's a totally wild fact for you. Bile contains a pigment called bilirubin. This stuff is exactly what gives bile its bright green color, and yep, it's also the exact same pigment that gives your poop its typical brown color.
Section 2. Anatomy of the gallbladder. Let's zoom in on the undisputed star of this network. This little pear-shaped sac is tucked snugly right into a groove on the underside or visceral surface of the liver's right lobe. Remember, it doesn't make a single drop of bile. It just stores and super concentrates it. Actually, this little sac is only about 3 to 4 inches long, but it can safely hold up to 50 milliliters of concentrated bile. That's roughly a shot glass worth of fluid just waiting there until you eat a heavy, fatty meal.
Anatomically speaking, we break the gallbladder down into 3 main sections. Down at the very bottom, you have the fundus. That's the wide, rounded end. And fun fact, if it gets enlarged, doctors can sometimes literally feel this part right through your stomach wall. Moving up, we've got the body, which is the main chunk resting directly against the liver. Finally, it tapers off into the narrowing neck, acting exactly like a funnel to guide the bile out into the cystic duct.
Now here's where it gets incredibly interesting. Right inside that narrow neck, most people have this tiny, hidden little pocket called Hartmann's pouch. This little anatomical quirk is often totally misunderstood because it doesn't look exactly the same in everybody, but medically, it is incredibly important.
So why does this tiny little pouch matter so much? Because Hartmann's pouch is an absolute danger zone. It is notorious for being the exact spot where gallstones get trapped. When a rock-hard little stone gets wedged into this pocket, it totally blocks the flow of bile. That causes massive inflammation and some really severe abdominal pain. In fact, a blockage right here is the #1 reason so many people end up needing a cholecystectomy, which is the surgical removal of the entire gallbladder.
Section 3. The intrahepatic biliary tree.
All right, we've seen the storage tank. Let's move backwards up into the manufacturing plant. To keep all this plumbing straight, medical pros divide the biliary tree into 2 halves. Intrahepatic means all the ducts hiding completely inside the liver. Extrahepatic means the ducts outside the liver. Right now, we're looking at the intrahepatic side, the liver's internal microscopic gathering system. Let's watch how this builds from the ground up. The liver cells, called hepatocytes, secrete fresh bile into microscopic tubes called bile canaliculi. Think of these like tiny neighborhood streets. Those streets merge into slightly larger avenues called the canals of Herring, which flow into bile ducteals and eventually into intralobular ducts. It's essentially a giant biological river system where thousands of tiny streams are constantly merging into bigger and bigger rivers inside the liver. And ultimately, all those merging streams finally come together to form 2 massive rivers, the right hepatic duct, draining the whole right side of the liver, and the left hepatic duct, draining the left. These two main pipes are the absolute final exit doors for bile leaving the liver factory.
Section 4. The extrahepatic biliary tree.
Okay, so let's follow the bile right out of those exit doors. We are now officially entering the extrahepatic biliary tree. This is the main external highway heading down to your gut. Those right and left hepatic ducts we just talked about, they merge to become the common hepatic duct. But hey, remember our storage tank, the gallbladder? It has its own exit pipe too, called the cystic duct. When the common hepatic duct meets up with the gallbladder's cystic duct, they combine to form the single most important pipe in the entire network, the common bile duct.
This common bile duct is a major descending highway, about 6 to 8 centimeters long, and we split it into 4 segments based on its path. It starts up above the intestines as the supraduodenal segment, and surgeons absolutely love this part because it's super easy to get to during an operation. From there, it ducts behind the intestines, sneaks behind the pancreas, and finally shoves its way right into the actual wall of the duodenum, which brings us right to the finish line, the ampulla of Vater. As the common bile duct reaches the intestine, it runs straight into the main duct coming over from your pancreas. They merge together in a perfect Y shape. This creates a tiny, swollen room called the hepatopancreatic ampulla, or, more commonly, the ampulla of Vater. This specific intersection is exactly where your bile and your pancreatic juices mix together, just a split second before they're dumped right onto your digesting food.
Section 5. Nerves and control valves. You know, a good plumbing system isn't just pipes, right? You need faucets to actually control the water pressure. Well, at the very end of these biological ducts, there are 3 distinct rings of smooth muscle acting exactly like faucets. You've got a sphincter for the bile duct, one for the pancreatic duct, and a final master valve called the sphincter of Oddi. When you aren't eating anything, these valves squeeze tightly shut. That stops precious bile from just dripping into an empty stomach and prevents intestinal bacteria from splashing back up into your sterile liver.
But here is where the system gets brilliant. How does it know when to open the valves? It's all automated by a complex neural network, including the vagus nerve. The second you eat a really fatty meal, your intestines release a chemical messenger called cholecystokinin. At the exact same time, your vagus nerve fires up. Together, they send a massive signal. They tell your gallbladder to squeeze hard and tell those sphincters to open up wide, flushing the whole system with bile at the exact moment you need it most.
Section 6. Blood supply and drainage.
Finally, we can't forget that these pipes are made of living tissue, so they need their own oxygen and nutrients. We got to keep the plumbing alive, right? You've got the arterial supply bringing fresh blood in, like the cystic artery branching off just to feed the gallbladder. Then you have the parallel venous drainage system pulling deoxygenated blood away. This whole area is just packed with blood vessels. That's a huge reason why any kind of gallbladder surgery requires absolutely incredible precision to navigate safely.
And there you have it, from those tiny microscopic streets inside the liver, down the giant common bile duct highway, straight to the powerful squeeze of the gallbladder. That is your biliary system in action. So, what's your biggest takeaway today? Your liver makes the bile, your gallbladder just stores it. If you loved this deep dive into your own anatomy, please hit that subscribe button for more simple, beginner-friendly medical explainers. Until next time, stay curious and keep learning.